All right, everyone. It is time for us to get started. Welcome back to another lecture for COM 426, Modern Web Programming. This is lecture 11. So today, coincidentally, we're actually going to be starting a new module. But this module is really going to be tying into the one that we have been working on with React. And for the rest of the semester, we're going to be using React. So we're still going to be talking about React today, but we're going to be kind of expanding upon it to go from just React for building kind of and managing UI to a more general framework for building web applications. All right, so the first and only announcement that I have for today is that there we go. A3 again was open on last time, and so it'll be due on Wednesday. A lot of people have already started from what I've seen, so great work there. Remember, we have office hours on Friday, on Monday, on Tuesday, and on Wednesday, so make sure that if you have any questions, because I know it's a larger assignment, definitely feel free to check it out, and looking forward to seeing your final implementations. Another thing that's not on here, but I will mention again, is if you're interested in attending HackNC, I believe the registration form is closing sometime around October 3rd, so sometime next week. So highly recommend if you have not been to HackNC before, or maybe you have done other hackathons but we're unsure, highly recommend that you register. There's going to be a lot of fun things. You can work on a project, maybe even use some of the stuff that you've been learning in 426, and you will have the chance to probably get free food and merch and all the other stuff. So highly recommend it. It's a great way to meet people, to build some apps, and maybe in the end have something to put on your portfolio. All right. So we're going to be starting off this section here by kind of rounding out what we've been talking about with React. The last three lectures, we've talked about React. We talked about making our UI with TSX. We've talked about managing states, and then last time, side effects. Throughout that entire time, we've been talking about that rendering process, of how we update our state, and the state changes our UI, and React manages that for us. Right? So React has added a lot of incredible things to our developer toolkit for building web applications. One of the main ones is composing our app and composing UI, in these things called components. And components essentially encapsulate, the UI and all the functionality for a specific part of your app. It makes it far easier to, for example, nest components, reuse things, and just build larger and larger apps. It also, again, as we've been talking about, it simplifies the workflow of how do we manage data in our application, and how do we kind of maintain the reactivity, where if we change this data, that we have our UI reflect, or our UI to re-render to reflect that change. So with React, we've been able to do this, and React handles a lot of the hard work and heavy lifting for us. Remember back when you were doing A02 in the fundamentals module, we've had to use things like event handlers, et cetera, to do that. And here, it's all managed by React. Again, this just helps to help us to ensure that our UI and our data remain in sync. And then finally, we also talked about Tailwind a bit, and you're maybe with A03, you're getting some practice using Tailwind. Again, we'll be having a lot more practice throughout the semester with it, so it's something that we'll be building up over time. But Tailwind is great because it helps us to essentially reduce this idea of creating UI using HTML and CSS, and also TypeScript. Everything can be combined into one component file so that all concerns regarding a specific piece of UI are defined in one place. Any questions so far? Amazing. What I want to highlight now with some diagrams is just kind of bringing us back to this idea of our client and our server, and how React kind of works in this particular model that we saw in the beginning. All right, so when we're in our fundamentals module, we talked about this, where we have our client, we have some server, and then maybe we have our project at the top. Right? And this is the project that we're working on in VS Code or any IDE of your choice. Right? So the first thing that we do is we develop our project, we write our code, and then the next step is we actually go ahead and build our project. Right? Building is this process of getting our code that we've written ready to be deployed right onto the server. Right? So you can see here that we can deploy using a tool like Vercel. When we deploy using Vercel, Vercel runs the npm run build command, and it will build our app using something like Vite. Right? So Vite has been building for us. And what this does is it takes all of our TypeScript code, it converts it into JavaScript, right? If we maybe had some tailwind, it will write a CSS file for us, so that ultimately, even though we're using all these very nice tools when we're developing our app, in the end, our app is still HTML, CSS, and JavaScript once it gets to the server. Right, so you can see here again, Tailwind makes one CSS file. And this particular JavaScript code, it's kind of important to think about what ends up actually being part of this JavaScript. So in something like A02, when you all took a screenshot of this, when you submitted your app, you saw the event handlers, maybe some of the things that you coded up, right? That was in your final JavaScript file that you got from the server. But also in this case, since we're dealing with React now, we have all these other pieces. Might seem a little bit strange. It kind of feels a bit abstract now. But in the end, all of the stuff we're using, all of our components, all of the TypeScript code, all node modules that we import for React, everything ends up in the JavaScript files that get placed on the server. Right, so even though we have all these things that we're working with in our app, in the end, what goes on the server is still just JavaScript. Okay? And it's important to note here is that the HTML file that we have ends up pointing to, in the metadata, using head or script tags to our CSS and our JavaScript. So that when we get the HTML file, we'll be able to also make a request for the CSS and JavaScript. Okay? Questions so far? All right. So after this build process, we end up with HTML, CSS, and JavaScript on our server. Right? So this could either be in our local dev server, right? So using our localhost 3000 or 426.0, whatever URL you get in localhost if you're using, if you're developing locally, or if you put this on the web, it is on the internet using Vercel, right? So this is like with A02, once you deployed, there is a Vercel server. Vercel has many servers, and one of those servers had your project on it. And then whenever you went to it with a URL, you were able to access these files. So now that we've built our project, I'm going to just remove that part. So now we're just left with our client and our server, right? This is the same foundational model we introduced all the way on the first lecture. And so what happens then when we load, I use localhost here, but it could be a real URL as well. What happens when we request our homepage on this site, right? So we make a request to this URL, and we get back, well, we get back index.html from the server. The same process that we had even in the beginning when we used our just a basic A01 or A02, right? You make a request and you get an HTML file back. Same process. So now after we load the HTML file, it shows up here in our client side. And once it's here in our browser, once our browser retrieves this HTML file, we then start rendering the HTML that we get. So what that means is, right, we have the HTML file, we then need to show it to the user, and so our DOM begins to be filled out. Now, what you'll notice, and if you open A03 and you go to the index.html file, and if you also kind of go back to our first React lecture, we know that we have our HTML now as kind of like an empty shell, right? We have like one div inside of it that's empty. And then React will go in and render the remaining components in that space. Right? So really here, the HTML we get back is empty. So our DOM tree doesn't really look like anything at this point. It is basically just an empty shell waiting for React to fill in the missing pieces. Right? So at this stage, nothing, our user sees nothing. It's an empty page because that is all the HTML that we got. Does that part ring a bell? Make sense? Perfect. Right? And so again, wrote up there, mostly empty because React will render this in later. And so at this point, while we also are starting to render, we are going to fetch the CSS and JavaScript files that we need for our site to work. So that index.html file has some metadata. It has a head tag. It has a link tag that point to, a link tag or a script tag that point to CSS and JavaScript respectively. And so we're going to then fetch for those resources, and the server will then respond with these files. again, same setup of how we had in our first module when we just had HTML, CSS, and JavaScript, right? So now we get our CSS and our JavaScript. Our client has these because we fetched for it. And at this point, we can then begin running our JavaScript code, right, from top to bottom, just like how we did before. Now, this JavaScript code that's here is been generated through this build process. And so React has a bunch of functionality that it is going to start running at this point. Because when we create our project with React and we have our TypeScript file and it all gets converted to JavaScript, we're going to start running that from top to bottom. And you'll see here what happens is that I'm kind of using this box to kind of pretend that we have like some React process running in our browser. Right? You can imagine here, even though I don't have it explicitly written, we still have our stack, we still have our heap, everything's still happening. And all that we're doing, we're just running our code from top to bottom. But while doing so, we kind of set up React and everything that React needs to make our app work as expected. So at this point, again, we've gone through the process. We have our HTML, our CSS, and our JavaScript file on the client side. We start running our React functionality. And at this point, React is going to render the components on the screen. Right? So this is like in the original, in that lecture, we had something like a create root, and then it was like root.render, and then a component. All we're doing here, we're filling in our blank HTML page with some React component that represents our page. Right? So we go from nothing on our site, user sees nothing, to React filling it in, and now we have a website that the user sees because they see the component that's been rendered. And of course, when we update the DOM tree, when React does that, the browser screen changes. So from the user's point of view, they see the website as expected. Any questions here so far? All right. And so then what happens is later down the road, right, our site now has loaded. So everything that we needed to do, it has been done here, and our website is now ready to be used by our user. What happens, though, is, again, at some point down the road, our user might interact with this website. And when that happens, right, you can see here some user interaction, maybe by clicking a button, running some function, or we update a state. Right? We have that here as an arrow. So you can see we have a user interaction, a state change. React notices that that happens, and then React will automatically update and re-render components when that state changes. Right? And that will update what the user sees. So in our same model here that you can kind of remember back, right? We have our UI, which is kind of like this part. That is extremely pixelated. Apologize. UI. Right? And then maybe in our React functionality here, we have our state. And so whenever we whenever we change our state, right? Maybe from UI, we change our state ends up, and React ends up re-rendering our UI. So that same type of diagram where we had UI and we had state, same thing is happening here. It's just that we're kind of now putting this in the context of a browser diagram rather than a more abstract model. Questions so far? All right. So again, when we say React, that we're building websites with React, really what React is it's just a tool that is a library that allows us to essentially compartmentalize our UI into components. We can render those components on our screen, and then React will update those components when some data changes. That is all that React is doing. Okay. However, React is in itself not all-encompassing. Right? It is just a library that does those core things. There are limitations to React on its own. And even though React is great, it allows us to do all these things, there are certain things that React is missing that we will end up noticing as we build larger apps. The key idea here, and this particular statement is memed upon a lot, because there's this pedantic fight between what is a framework and what is a library, and somebody will always say, oh, React is a framework, and then someone is like, well, actually, no, it's a library. And really the difference here for our purposes, this distinction ends up meaning something as we build larger apps. Libraries are specific tools that we tap into and that we use, but frameworks are kind of like a complete system for building applications that incorporate all of the tools that we might need to build an app kind of in one toolkit. So you can think of it like a framework is like a toolbox, a library is like a specific tool in that toolbox. That's kind of the type of analogy that we use when we describe libraries versus frameworks. Again, wording wise, it's not that serious, but it is kind of a differentiating thing when we talk about this to be aware of that, well, React is just one tool, but it's not a complete package. What do we mean by that? Well, we're going to get into that now, right? React does not have a built-in way to be able to change pages in an easy manner. What that means is, for example, if I'm on the home page and I switch to the about page, right, we end up, and we'll see this in a moment, we end up making a new request to the server, we get a new HTML file, and we restart from scratch, and React will re-render the component. React does not just take the current active component and swap it out with a new one when we change pages. We're going to see this in a moment, but this does have very important implications for user experience. What I mean, and let's see an example of this here. So I'm going to open up StackBlitz. I'm going to try to open in a new tab, so hopefully this does not break. There's a specific feature of Safari I will be using later, which is why I'm using Safari today. So let's go into it and connect to our project. So you can open this link up, and you'll see that this is a website here. It's a very, very simple website that just has two pages with different colors. We have a blue page here that's our home page, and we have a link to an about page. And when I press on the about page here, right, we end up loading the about page, and it's red, and we have a link for our home page. Right, so very simple. There's just two different pages. And when I click like so, we end up just switching between our pages, right? And so what I would like you to think about now, given this model, and I guess I should also show my code a little bit so that it maybe makes this more contextualized. So we have index.html here. And just like I was saying before, right, index.html is it's an HTML file that just contains a div, right, one single empty container. And to this, we link this index main.tsx file. And in here, we just take that div and render a component inside of it. That is the process that's happening here. There's also an about.html page for our about page. It has the exact same thing, except it renders the about component instead of the home component. Notice that these are two separate HTML files that I have, and also that I have two separate kind of main.tsx files that are loaded in that render these pages individually. Now, just looking at my particular diagram here, you can kind of think of this as our client and our server. What's on the dev server, and what is on our client. You can kind of clear this out, and I'll maybe draw a blank diagram. And what I would like you to do is to think about, based on this diagram, what do you think happens if we're on our home page and we're loading our about page? We press on that about page link. What happens, right? Would the client need to make any requests to the server? What ends up happening with these files? So I would like you to write down your thoughts. If you don't have to, if you have like a tablet or something you'd like to draw it, feel free. But you can also just write it, since I don't have paper today. A bit of a recap here just for our diagram. We have like a diagram that has two parts. We have the server. We have the client. On the client side, we have like the page of like what the user sees, so like the browser screen, and then we have the DOM, right? So these are kind of our different pieces of our diagram. So the next 5 minutes, try thinking about this, and then we'll come back together and discuss. The attendance check should be open to submit. There might be a secret word today, and in fact there is. So the secret word is going to be, let's see, what should I do here? We'll do router today in all caps. So this will be our secret word. All right, everyone. I think there were some good discussions. Make sure that you submit your final thoughts to Gradescope for the attendance. Make sure to also include the secret word for today. Any thoughts on? First, I would like to ask the question that's on the second, next to the second bullet here. Would the client need to make any requests to the server, right? So we're on the home page, we're trying to load the about page. Is there any request that has to be made here? Thoughts? You can either shout it out, you can raise your hand, someone can. Anyone? Yeah. Yes. What would we ultimately, or what request or requests might we have to make? Thought process. Mm-hmm. Exactly. Yep. Perfect. So yeah, in this case, right, we have on the client side, we have the index.html page, but in order to load the about page, we need to load the about.html page. Once we load that in, then we'd also need to reload all the CSS, JavaScript associated with that page, et cetera. Perfect. So let's see this in a diagram. And this, you can kind of begin to check to see, based on what you're thinking in terms of the mental model with what is really going on here. So let's get this to reconnect here. Oh, wait, that's why. Okay. There we go. Okay, so again here, I have modified my diagram to kind of represent what this might look like. We have index.html, we have about.html, we have CSS, and then we have some JavaScript that is the result of our build step. And so when we loaded our index.html, right, again, this is just showing, recapping that process. We fetch the index.html. All that crazy stuff happens where we grab the CSS, we grab the JavaScript, we start loading React, and then React renders, and we have our homepage on the screen, right? That is the starting process. What happens when we load the about page? Well, we're going to make a request for about.html. And when we make this request, what ends up happening is everything that is currently in our browser is completely erased. So the DOM is reset. All of the files that we downloaded are discarded. And what the user sees as well turns blank, right? We have kind of a white blank screen because everything has been erased. Then we restart with our about.html file. We have to then go through the entire process again where we refetch our CSS, we refetch the JavaScript, we set up React a second time, and then React will render our about page on the screen, right? So again, very important here to note that throughout this process, everything, all CSS, all JavaScript is all loaded again. An entirely new React instance is spun up again in our browser. So everything, all of React's functionality, we reset it up. And because of this process, the user will see kind of a flash, right, of a white page on their screen while they wait for the new page to load, right? Because everything has been wiped and we have to restart from the beginning, right? Now, what I want to do again here is I want to go back to my example and notice, you can just look, there's a reason why there's a color here on the background. You can see that as I switch between pages, right, it's a fast process here because there's only two components. But we have right when I press this link, and you can watch the loading bar as it goes from left to right. Right when I press it, we have a white blank screen. And then after we load, we have our actual page show up here, right? So this process of restarting everything from scratch and re-spinning up our process is what our current model ends up using. We fetch a separate HTML file every single time for each new page. This particular process and this particular architecture of a web application is what we call a multi-page application. This is often abbreviated as an MPA, multi-page application. So every single time, all an MPA is, every single time we navigate to a new page, we will request a brand new HTML file, that should say file, not page, essentially blowing up, deleting everything that was currently running in the browser and starting again from scratch. Right, so that is the MPA model. There is a alternative way, though, to do this, because our model here with our MPA, and by blowing up all of our processes, we end up adding this extra white screen. Our page becomes, our loading is slower because we have to restart, we have to reset up all of React, reset up all of, restart running our JavaScript, building out everything. And so, and the downloading process, right, of downloading these files can be slow as well. And so that ends up adding kind of this delay for the user, and user experience gets a bit worse. And so there's an alternative way to think about this, where we can avoid that from happening. And that is by using something called a router. A router is a library. So again, just like React is library, a router is a library, or it is a tool, same synonyms here, that hijacks this traditional process of us loading a page. So typically in the browser, whenever we navigate to a new URL, we will go and make a request for a file, an HTML file at that route, right? When I switch between my home page and about page, I request a new HTML file. Or if I go between Apple and Google.com, I end up making separate requests for different HTML files. What a router does is that instead of using the built-in HTML A tag, which is used to make links, so when you press on it, it makes a request, it will have its own link component that allows it to essentially modify that process. So we prevent, the idea behind that is that we use an internal process, we start up an internal process to change our page rather than actually create a new request. That's the first thing. The second thing is when we press that router link, so again, not the A tag anymore, we're pressing the router link component, the router will clear the DOM, like in a sense, remove the React component that's on the screen, and immediately replaces it with another one. Okay? And then the router will go to the URL that is currently active on our browser. So it might say like localhost 3000 / and it will modify that in place to change to localhost 3000 / about. We never actually really make a new request. It is essentially just changing what the user sees on the browser in terms of what route is active. And it uses particular browser APIs to override the browser behavior. So we never end up completely clearing all of the JavaScript code that we run. So it'll make more sense in a diagram, so I'm going to show that next, right? So you can imagine here, we're going to have our same type of React app, but using this tool called a router this time. So I load my home page as before. Nothing changes in this process. I load my CSS and JavaScript. I start up React. But this time, in addition, as part of my JavaScript, I don't just have React, but I also have a router as well. So you can see here, we have React and we have router. And then React will render our component like normal. There we go. So our site has loaded successfully. The only thing now that changes is the process by which we change the active page that's on our screen, right? So what if we try to navigate to the About page? So instead of pressing on an A tag link, so I might draw this out to make it a little bit more clear, right? Before we had something like A, href equals, and then about. This is what we may have had before. This time, we're going to use some link component that has been provided by the router library. And it might have something like href equals about. Or it might be called path. It might have a different property name. But essentially, we're replacing our standard links with this new link component. And so now, when we change to the About page, we're going to click on this particular component, not an A component. And what happens then when we do that is, let's see here if we. There we go. So we press on the link, and then the router, instead of us making a new request for the index.html page, the router is simply going to instruct React to swap out the current component that is in the DOM. Because the idea here is that all of the components in our project, because all of it is TypeScript and all of it is ultimately in our JavaScript bundle here, right? Even though only the home page is being shown, all of our components are kind of living in these files. So instead of making a new request to go and to restart the process, let's just use the component that's already in our bundle. It's already in the JavaScript. Let React just render it. And so what happens here is the router instructs React to instantly replace the currently active component with the one for the about page, like so. And then at this point, so we've changed our page, right? We've swapped it in place, but notice that our URL is still just our home page, right? Because we never actually made a new request to the about page. We never really changed our URL. And so the router will then, after the fact, go in, it hijacks the browser's process and just changes in place the URL that the user sees. So we don't actually make a new request. We don't really load a new page. We're just, the router is just making it look as though we have changed our route. Okay? Any questions so far? Yeah. Mm-hmm.
When they get to do it, are they getting all the separate JS files for all the different pages?
Yes, typically yes. So all of these, all the files that are in our TypeScript code, it gets built. So there's a minimization process that happens. So it shortens names. It tries to make it as small as possible, and then everything gets shipped in the final JavaScript. Yep. So when we end up getting our main JS, most of the time, all of our components will be part of that bundle. Yep. Any other questions? Yeah. Yeah. Good question. So we're getting into this. So the main difference here is that in this process of using a router, the React instance and all of our JavaScript code and everything, we never have to reload it. So the same JavaScript that we had before is still loaded by our client. We never have to make another network request, which is a slow process, right? Usually going to the network request, it might take 300, 500 milliseconds. It might be slow. When we do this method, we never have to make a new request to the server at all because all of our components are already downloaded. So we don't ever have to go to the network again to essentially get all these files, restart our React process, run everything from top to bottom, and then show the new page. All we do here is we say that in our initial load, so when we load it for the first time right here, when we load our JavaScript and CSS for the first time, everything we need for the entire app is in there, including all the pages. So it's kind of loaded at once. And then after that, we never have to talk to the server like after that point, unless we're like trying to load something else. But for loading pages, we don't have to talk to the server. We just use what we already downloaded. Does that kind of perfect? Yeah. Good question. Yes, so it is different. The main difference here is the link. So the one from the router usually starts with a capital L because it's a component. So it's kind of a React component itself that has the routing functionality in it. The link tag that's used in the metadata is lowercase, and that's built in HTML. So it's kind of an HTML component. Yeah, good question. Yeah. Good question. So it removes what's in the DOM and then immediately replaces it. So yes, we do clear the DOM, except it's a much faster process because if you imagine, right, the DOM in the end is just a tree data structure. If we have the reference to the head, we just can immediately swap the child node, and that's like an O of 1 operation if we render the component. So it's a very, very fast process. But what we do eliminate is the process of having to go to the server, request new files, rerun our entire React instance, which takes a lot of time. Good questions. Let me catch ourselves back up here. So again, the main thing here that makes this good is that we don't have to go to the server for a new page load. It essentially, from the user's point of view, page changes happen nearly instantly, where we just take a current page that's rendered and we immediately swap it out for a new one. We never have to wait hundreds of milliseconds up to a second for the network request to be made to the server to get the new files, reset up React in our browser, and go from there. Again, the key thing here with this, and this is highlighted here, and we've talked about, right? The key reason, or the key thing that makes this all work is the fact that this JavaScript here contains all of our React components, not just only the one that was loaded, all of them. And that's what makes this process possible, because we have all of them, right? All of our components, both our home component and our about component, are sitting here downloaded. So we can just, instead of making a request to get the about component, we can just switch to the about component immediately. Questions here? Yeah.
Like
Mhm.
we went from designing it, like big, and then another PS file.
Yeah.
PS file, and then it just.
It's a good question. So in that, the process that React uses and that Vite uses to build it, the final JavaScript you get out it's not a one-to-one. So it might rearrange files, it might add things to certain files, it will rename variables, try to minimize it as much as it's possible. So basically the amount of bytes that file really is reduced. So the idea is to like make the network latency go down if they're smaller. Yeah, so if there's some things like strings, for example, those will still be in there. So like if you have a string as a title, you'll be able to find it in there. It just, everything else around it, kind of our code structure, things would be changed. Yeah, great questions. This particular approach that we're using now with the router, where we essentially download the entire app, all of the necessary functionality at once, and then we use a router to kind of hot swap whatever our active component is. This type of app is known as, and for some reason, there we go. There we go. This is known as a single page application, or an SPA. Very common abbreviation. And unfortunately, in this module, there are a few abbreviations that get, so it might be a little bit hard to think of it. You can use the full name if you prefer, right? We have MPAs and now SPAs, multi-page app, single page app. And the idea, again, with a single page app, kind of summarized here, is that the entire app loads once on the client. Everything you need is downloaded. And then the routing actions just change whatever component is active. We never have to make another request to download more files because we have everything at once, right? And so then when we're building applications, we can choose a combination of tools, combination of libraries to make an SPA possible. In this case, we have React for our UI, and then we add some router. These are all tools, individual tools that we can combine together to make an SPA application. However, we can also choose a framework. Remember, framework is like a toolbox that has everything included. And so we can just start developing using this framework, and it will have everything that we need combined together. And that is what we're going to be doing as we go forward. Because most of the time, frameworks come with their own router so that we can make this process work. By a show of hands, who here was in Chris Jordan's like 590, 423 class? Perfect. So connection to that class. If you're in that class, Angular is an SPA framework. So Angular has a router. It is changing the active page that is shown using a router. And even though it's not using React to specify UI, it has its own Angular way of doing it. It still has a router, and therefore it is an SPA application. And we're going to see in a moment, we'll have an Angular app open, and you'll be able to see this work. Any questions with this? Right. So based on this lecture, based on my tone and how this is going, you're probably assuming that, okay, an SPA superior to an MPA, because that is, that's how I'm presenting it so far, is that it's superior for a user experience. But can we think of any ways that are actually worse here than an SPA? So in particular, what I want to note here is how do users, when navigating the internet, actually find new web pages, right? They use up until this point, who knows what'll happen with AI, but we've been using search engines, right? Like Google. Using Google, we can find some web page on the internet that is relevant to what we're searching, and then we can access it. How does this actually work? Well, search engines typically have these little programs, or crawlers as they're known, that load millions and millions, if not billions, of all the different web pages on the internet. And it looks at what loads so that it is able to categorize that content, right? And so, for example, if it loads the CS UNC-Edu website, it notices that, oh, okay, this is about UNC, it's about computer science. So if someone searches UNC computer science, it'll show that web page, right? The main key problem, though, with this is that many crawlers cannot run JavaScript at all. So it essentially loads your website. It sees the HTML that's loaded. It might have the metadata as well that you put in the head tag of your HTML it might use that to categorize the site. But if it can't run JavaScript, then nothing that requires JavaScript to work will actually appear for the browser. And so the problem here is that in an SPA app, if there's only one index.html file that we have, and we use JavaScript to load all of our pages in our app, right? Because we do not have individual HTML files. In their home page and about page are just loaded by React. When we have one index.html file, well, then a crawler for a web browser, or sorry, a search engine, is never going to know that both of those are two separate pages that exist and that are, and it would not index these differently, right? And so if you have something like a blog where you have hundreds of pages that are not necessarily related, they all have different unique content, then using something like this in its current form might be bad, because all of your blog pages are not, like, the browser is not seeing all of them individually. It's just seeing your one index.html page, and that's it. Or if you have an e-commerce site where you have a lot of different products that you want to search, that you want the users to be able to search on Google, for example, well, if they're all on different pages and you're using this type of framework, an SPA, then you will not have your pages, your individual pages, be viewable by a search engine, right? And so what I would like you to, I wrote in this slide, and I was trying to remember how to do this. So you can watch me do it, because I think in Chrome, they changed, I think, where this is located. In Safari, it's very easy to find. So I'm going to do it in Safari just to kind of show you. But I think if you have Safari, you can try this. If you are on Windows, you can follow along. And I know there's a way to do it in Chrome, but I wasn't able to reliably find it. But there's a way in our browser to actually turn off JavaScript so that you can essentially simulate what the search engine or what some crawler would see. Because if the crawler cannot load JavaScript, well, what will our page look like? We can check that out by essentially disabling JavaScript on our browser so that it never ends up running it. And so I have both of my pages here, where I have my home page and I have my about page on my on my original site. And I'm going to go in and I'm going to disable JavaScript. So to do that, I'm going to go to Inspect. And then if you're on Mac again, there's this button here for a device on the left-hand side, and there's a very nice check mark for disable JavaScript. So you'll notice what happens when I press this here. And if I refresh my page, right, you'll see nothing shows up because React is responsible for rendering our site. And so without JavaScript, nothing shows up here. But we can also look in our HTML directly to see if there's any data. You'll notice here that we do have metadata in here. And in this metadata, there is a title for our home page. So that is some discernible information for a web browser. You can also put other important information in this metadata section. And so your browser will be able to see that, like a website description or something else. And so that's useful. And if I were to change and I go to my About page by doing About, you'll see that it loads a new page. And in this page here, we have a separate title for our About page. So we end up seeing in our HTML different, even though there's nothing on here yet because we're using React, in our metadata, there's differences between our homepage and our about page, which a search engine crawler can use to index these pages. Now, I want to go to an example of a pure SPA site, which coincidentally is the CSXL website you use. So if we go over to csxl.unc.edu, there is a new bug, by the way, I think in the new Mac OS version that stretches this image. So hopefully we'll fix that later if you noticed it. I'm going to disable JavaScript here. And I'm going to refresh my page, right? And so you'll see that, again, we have nothing actually is visible to the user. And we also have nothing as well really in our body. So you can see here we have no title. We have nothing else because we're on our home page. And if you compare this HTML to all the HTML for all the various pages, so like if I went to the About page of the Excel website, so I change from welcome to about, right? We end up loading the exact same HTML. Nothing changes between these pages. I can even go to the organizations page here for the list of all the CS organizations, and nothing changes. We have the exact same HTML. And I realize head was closed, but you'll see here that there's also nothing discernible in here. The title is still the same of the home page, which says CS Experience Labs at UNC, right? So even though we have an SPA app like the CSXL website, when it comes to search engines and kind of making our page more accessible to people on search engines, this particular approach ends up being slightly worse. Because if the HTML file for every single page on our site is the same, a search engine that cannot run JavaScript will have no way of discerning what your website, what's on your website, what it's about, what different pages exist on your website. It just only sees the home page, and that's it. Questions so far? Okay. What we're talking about here in particular, and what we are optimizing, is a very important consideration for web engineers and for full stack developers. It's called SEO in particular, search engine optimization. It's this idea of how do we engineer our site in a way that makes our site more accessible to more people on the search engines like Google, right? The idea is that we want to make our site appear more often to users when they type in something something in Google, so that people end up going to our site, right? And so if we end up kind of having this model with an SPA where we have very good user experience, we don't have this choppiness, and we're reusing our HTML page, so users don't see this white flash every time they change pages, and we don't have to reload everything and have all this inefficiency. That's great. However, by doing so, we hurt the ability for new users to be able to find our site. And so ultimately, for SEO, this multi-page app approach ends up being better than the SPA approach. But for everything else, user experience, interactivity, for speed, for everything else, SPAs are better than MPAs because, again, every time we change our pages, we don't need to reload and essentially restart our website from scratch every time. Questions here? All right. So what we're going to be moving what we're going to start introducing next week is a framework that essentially provides us a router, just like our SPA approach. However, this framework has a lot of modern approaches that essentially ends up being a hybrid of both our MPA and our SPA approach. The goal of this framework is to provide the best of both worlds, where you have the UX, you have the speed, you have the interactivity of an SPA, but you also do not sacrifice search engine optimization when it comes to how our pages load. And so this particular framework is called the Next.js. Next.js, I believe, is a it's been around now for many years. It's been widely adopted. It is and I think I might have I don't have a slide on this. I think I have a slide next lecture, but is one of the most widely used React web frameworks, right? So when I say that, what I'm saying is that it is a framework that uses React to build user interfaces, and it uses components and everything like we have done in something like A03. But it also includes a router that allows us to handle changing our pages. It also uses Tailwind and TypeScript for better developer experience, for dealing with styling, as well as for type checking. So all of the tools we've used, TypeScript, React, Tailwind, and now a router, are all included inside of Next.js. So when you build a Next.js project, you will be using React, you'll be using Tailwind, you'll be using all the things that we have learned, but it's going to be managing a lot of the architectural side for us. In particular, the architecture Next.js uses, again, is a hybrid of the MPA and SPA approach. And the goal is to not just have what we had before, where we kind of have a trade-off that we have to choose. We want to get everything in one package. How this is particularly accomplished uses a very essential technique in the web world that if you read, especially as new frameworks are being developed and as people are building in large projects and even building frameworks, this particular approach is a foundational part of how web apps are architected these days. And it's called server-side rendering. It's abbreviated as SSR. So that's our third abbreviation. We'll be talking about it next time, but even frameworks like Angular are beginning to adopt this model. Because again, we're trying to get somewhere in the middle where we have something like an SPA, where we don't have to go to the server every time to load a new page, but we also have what we receive from the server the first time is very good for SEO and is different for our different pages. And so we're going to be talking about this and how Next works and SSR and all this stuff next time. In the meantime, though, I want you to play around with A03 as you develop it. A03 uses the MPA approach that we talked about. So as you switch, for example, between Wordle and connections, I would even encourage going into the browser network tab and see that you're loading JavaScript every single time that you are making these requests, because understanding how this stuff works behind the scenes ends up making it makes your knowledge of building web applications more well-rounded. And in an industry where things like user experience, speed, search engine optimization, all these things are important, you will have the tools and the knowledge to be able to discern and to optimize all these different things. All right. So I think we're also going to be finishing a little bit early today. So you can go and if you don't have a Friday class, you can enjoy your weekend. If you have any questions, feel free to let me know. We'll see you all on Tuesday.